here we go. This is cool. I found a stats section for OBS. So, just trying to throw this in here somewhere. Back to the Associate Cloud Engineer Study Guide. So that there's a link for that. Through. Wow, I just closed everything up here, didn't I? Let's see, Associate Cloud Engineer. Anyways, so I was writing on here through Google Docs. I mean, I can still use this for a bit, but also wanted to try making notes on straight on the PDF. So I made it just a file just called edit. It's the exact same file. Burp. And go down. I just like how neat it looks. Chapter 8? Whoa, that went way far down. I think I just stopped off at chapter 2. Yeah, in chapter 2. Chapter 2, review questions. So, here we go. You can find answers in the appendix. Yeah, I'll check that later. You're planning to deploy a SaaS, something as a service. Oh crap, I forgot what SaaS means. SaaS. Oh, SaaS, that's right. SaaS is, it's like CSS. Software as a service. God. Let's see if I can highlight it. Cool. For customers in North America, Europe, and Asia, to maintain scalability, you'll need to distribute workloads across servers. A workload across servers. So that's why I like my Google Docs, but I only have up to, it would only, so basically what I did is I took this and turned it into a Google Docs, but it only did so many pages, like 30, 40 pages. But there is a bit that includes compute, storage, and networking services. So this is chapter 2, Google Cloud Computing Services. This is planning and configuring compute resources, selecting appropriate compute choices for a given workload, deploying and implementing data solutions, including initializing data systems. Get rid of this. I'll just diff. GCP is made up of almost 40 services that meet a variety of computing. Yes. GCP is a suite of cloud computing services that can compute, storage, and networking services designed to meet the needs of a wide range of cloud computing customers. Yes. There's a lot of space in there. Why didn't they go all the way to the end? Oh, here it is. So that was page 17. Public cloud services provide a range of computing services options. How did this pass the official guide with so many errors? This is just a copy error. At the end of the spectrum, customers can create and manage VMs themselves. An alternative model is called, there it is. See, I have to memorize this. Platform as a service, software as a service, infrastructure as a service. This is what I use at work. This. So, Users can choose the operating system to run, which packages to install, and when to back up and perform other maintenance operations. That's the whole infrastructure as a service. I use that with Terraform. Oh, they got software as a service. Infrastructure as code. Ooh, IBM. I love any movie that has IBM in it. Alternative model is called Platform as a Service, which provides a runtime environment to execute applications without the need to manage underlying servers. A key, compute engine. Looking good, looking good. Running with a hypervisor. What is that? Was page like 17, I think. Whoa. This might be it. It's really hard to tell. Chapter 1. Oh, it's just chapter 1. Then there's something down there. Ah, that's what wasn't copied over. So the PDF works better here. You can see the VM instances running with a hypervisor. So I'm going to have to just get rid of this whole thing, because it just doesn't look right. Oops. Yeah. Oh well. There's a few things that don't get translated over very well. There's a physical server, an actual computer, host operating system, the hypervisor. Interesting. Let's just do. What is a hypervisor?
According to Wikipedia, a hypervisor is similar to an emulator. It is computer software, firmware or hardware that creates and runs virtual machines.
Oh. Okay. And most popular, probably the coolest, VMware and Red Hat creates and runs VMs. Okay, cool. Gotta love Red Hat. Cool, cool. And there's the 3 VMs on here. Ubuntu, Alpine, and Windows. That's cool. VMs come in a range of predefined sizes. You can specify a number of parameters. Operating system, size of persistent storage, adding graphical processing, making the VM preemptible. Will frequently be shut down if a preemptible is. Yes, there it goes, 24 hours. We just did that. There we go. Ooh. Wait, I can highlight this too. Yes. What if I keep that thing on? Yeah, there we go. Keep it on. Chapter 4 will introduce the details of managing. Chapter 4. Talking about chapter 4. Let's focus. Kubernetes. Containerized applications on a cluster of servers. Very cool. Containers are compared to VMs because they're each used for isolating computing, processing, and resources. A virtual machine runs a guest operating system on a physical server. Oh, so here we go. Container manager. Okay, that's cool. So the container. Whoa, oh, man, this thing is huge. Just like, oh no. Yeah, there it is. Like a hypervisor. I was trying to go to that. Container manager's like a hypervisor in that sense. There's no need for a hypervisor. The host operating system maintains isolation. So this is like the next step up. A little better. Container manager is used. Single container manager coordinates containers running on the server. No additional or guest operating systems run on top. Oh, there's no operating systems on these. That's why. No additional operating systems run on top. That is really, that's every single day learning something. This is cool. I'm just going to scroll up. So on a hypervisor, you have Ubuntu, Alpine, and Windows on top of this, and that's going to eat up resources. Wow. Very cool, very cool. That's why everybody loves Kubernetes. It's just a container manager with containers. Wow. Wow, wow, wow. I love this. Yes, Kubernetes is a Google's product. Google created it. It's easy to add and remove resources. Easy to add and remove resources from a cluster. Using the CLI, GUI. Kubernetes monitors the health of servers in the cluster and automatically repairs problems. See that? Everybody likes that. Also supports auto scaling. Kubernetes engine will also allocate additional resources. No, I'm not going to chapter 7. App Engine. App Engine is platform as a service, software as a service, infrastructure as a service. Remember those three. Developers, application administrators don't need to concern themselves with configuring. Don't need to configure VMs or specify clusters. Create applications in a popular programming language, Java, Go, Python, Node. So I went from JavaScript, Java, now Go. I guess maybe in the future I'll learn Python, but I suck at everything, so. App Engine is well suited for web and mobile backend applications. That's cool. I memorized that. Standard and flexible. Standard language specific sandbox. The application is isolated from the underlying service operating system. Standard environment and well suited to applications that are written in supporting languages. In the flexible environment, you run Docker containers. And this is, I think, more popular, but also need libraries or other third-party software installed. Okay. That's cool. I'm used to that. JavaScript, Java, Node for JavaScript. Node.js. As the name implies, flexible gives you more options. Background processes and write to local disk. I don't know about that. Not talking about other chapters. Cloud functions. Lightweight computing. Yeah, it's just the functions. Runs code in response to an event. That's all you have to know. Must be short running. The computer service is not designed to execute long running code. Must be short running. Cloud function is often used to call other services. Man, they got all the answers down here. We were just talking about that. App Engine Cloud Function serverless. Users only need to supply code. They do not need to configure VMs or create containers. Automatically scale. In addition to four main computing products, number of storage resources. No, not talking about other stuff. Storage. Cloud storage is GCP's object storage system. Now they get into it. This is like all the answers. Objects can be any type of file or binary large object. Objects are organized into buckets. Is this chapter 2? Because that was what I was just tested on. Why do they do it backwards? Objects are organized into buckets. Okay. Yes. Which are analogous. How do you even pronounce that? How to pronounce analogous? That's not even. I can't even. Analogous? The same as. Analogous.
Analogous.
Analogous. Never use that. Synonymous. Analogous versus. Whoa. It must be the opposite. Synonymous. Analogy. Bearing resemblance. Similar meaning. Bearing resemblance. So same sort of shape. Wait, what's the homologous? Wow. Like organisms. To directories in a file system. Okay. Cloud storage is not a file system. Okay, I just learned that yesterday. It is a service that receives, stores, and retrieves files. I just didn't know that's how it worked. Cloud storage is not part of a virtual machine in the way an attached persistence disk is. Not part of a VM. It's accessible from a VM. And so complements file systems. Okay. That's what you need to know. On persistent disks. Each stored object is uniquely addressed. Yes. Yes. What is this? Whatever. I have to look it up. Does that not work? All right. Wonder how I can fix this. Cloud storage. It's blocked off. telling the rest of the world go there, but they've blocked it off. Why don't I just cross it off somehow? Google people, update your stuff. Cloud storage is useful for storing objects that are treated as single units of data. There are different classes of cloud storage. Regional. It's like pretty much the most expensive, right? Multi-region storage, even more expensive. Oh man. HA. Data needs to be kept for extended periods of time. Cold storage, low-cost archival storage. Less than once per year. So what's less than once per year? Once per every 366 days? Cold storage. Alright, I'm ready. Life cycle management. Plasmas all objects. Nearline. Whoa, is my back heater in? This feels really warm. It's not even on. Persistent disks are storage services. Wait a second. Difference between Coldline and Nearline.
Here's a summary from Google Cloud. Nearline storage is a low-cost, highly durable.
No. Multi-regional, regional, Nearline, Coldline. Oh, so okay, so Coldline is the longest. I thought there was an archival. Yeah, there's an archive. Nearline, you have to store it for 30 days. But where's the one where it said like a year? Less than once a quarter, less than once a month. Yeah, Nearline is supposed to be less than once a month. Once a month, once a quarter, once a year. Let's see if we can go here. And when has this been created? I wish that's a date on it. This looks like the most recent. Google Cloud. Current archive. One of my buddies is taking the certification test tomorrow. I'm gonna take it in a few days. Oh my god. Oh wait, I'm lost. Oh, I've been writing on the other. Oh well, just keep on going. Persistent disk. At least I say I know it. Storage devices attached to VMs. Provides block storage on solid-state drives. Often used for low latency. Yes, we all love SSD. want to get distracted. SSDs cost more than HDDs. HDD. Yep, we all know that. With our own computers. Up to 64 terabytes. Well, that's cool. Cloud storage for Firebase. Storage for Firebase to be the best combination of cloud object storage. The best combination of cloud object storage and the ability to support uploads and downloads from mobile devices. Secure transmission as well as robust recovery mechanisms to handle potentially problematic network quality. Once files like photos or music recordings are uploaded into cloud storage, you can access those files. That was based on... What was that the other day? I was just talking about... Firebase network file transfer. I think it's just NFT, network file transfer. Is that what it was? I feel like going back. Yesterday, network. Network. Cloud. What file technology? Yeah, this one. IaaS. No. Was that it? NFS. Network file system. Isn't that what I said? Yeah. Next. File store. So... network file transfer, network file system. Difference between file store and Firestore? Wait, what is it? Firebase and Firestore.
Here is information from Back4App blog.
No. Firebase. Difference between Firebase and Firestore. Okay, here we go. So this is Firebase, little origami looking thing. Firebase is business as a service. Firebase. Firestore. File store. I think File Store turned into Firestore. Oh my god. NoSQL Cloud Database. Yeah. The store's on fire. No order. Firebase. Cloud object storage and the ability to support outloads and downloads from mobile devices. Oh, okay, it's already highlighting. Designed to provide secure transmission, robust recovery mechanisms to handle potential problematic. Handle network quality. That's cool. That's Firebase. Firestore. Wait, isn't Firestore called Firestore now? Oh my god. Firestore now called Firestore. I'm pretty sure. Pretty sure this is how it is. File store. And then Flutter came out. Oh man. Firestore implements the network file system. Yes, that's it. Network file system protocol, so system administrators can easily mount shared file systems on virtual servers. Storage systems like the ones just described are used to store coarse-grained objects like files. When data is more finely structured and has to be retrieved using query languages that can describe the subset Google Cloud Console. That's it. IOPS. Input-output operations per second. Oh yeah. Oh no, I'm about to run out of time. Input-output operations per second. Variable storage capacity. Oh, I feel better. Just had to wash my face. Several database options. Some are relational databases and some are NoSQL. Yeah, it's either relational or non-relational. Some are serverless, others require users to manage clusters. Okay. Okay, and this is different databases. So this is a lot for chapter 2. Cloud SQL. Oh shit. That's about it. Here's Bigtable. My best friend over here. Almost coming to an end. Gotta end soon. Petabyte scale applications that can manage up to billions of rows and thousands of columns. I'm about to have on like maybe 2 headsets. Petabyte. That's Bigtable. Bigtable. It's giant. Do you think Bigtable's a giant table? A big fat table. I guess I'm just gonna save it. The heck? NoSQL. Known as a wide column data model. Heard of that. And unlike, yeah, wide column. It supports relational databases. Bigtable is suited for applications that require low latency read and write operations. Why did they write that backwards? Write and read. Designed to support millions of operations per second. Yeah, it's amazing. Is that what it says down here? Single digit millisecond latency per entry. Oh hey, I'm fast. Use me for heavy read-write events. NoSQL wide column database. Love this. Real-time analysis of large datasets. Ad tech, fintech, IoT, gaming, time series analysis. Actually, probably should just go back to that. This is my picks. It's my favorite one. Storage, which database? I'm talking about the databases. Cloud, Bigtable, NoSQL, non-relational. The other one's Firestore, cloud native serverless. NoSQL. So, what is a serverless application?
According to Amazon AWS, a serverless architecture is a way to build and run applications and services without having to manage infrastructure. Your application still runs on servers, but all the server management is done by AWS.
It just means the management's done by GCP. AWS is so far ahead of Google Cloud. Google's finally getting into it. It just means you don't have to manage it. That's all it is. Large-scale, complex, hierarchical data. IoT. I wonder what's the difference from Firestore and Bigtable. I'm seeing here document and key value. I guess key value pairs. Document. Maybe this came later. Well, I gotta go download it, look at it instead.